Okay, so hello everyone. So the topic that we're going to look at now is on selective repeat ARQ protocol. So as you're now aware of the problems that we have in the go back in approach, right? Where if it's a noisy channel, what happens is that all the outstanding frames has to be retransmitted again, which means resending all these frames is only going to waste your bandwidth, right? And also slows down your transmission, right? So having said the idea of selective repeat is to address some of these issues of go back in, where we will see how selective repeat ARQ further improvises it. Right. So having said go back in, what does it do? At the receiver side algorithm, if you look at, it's very simple algorithm. It's just the same as stop and wait because the receiver is only expecting only one frame at a time. If it's like getting that in order frame, he will process that frame, deliver it to the network layer and process the next frame. So there is no complications in that, right? And there is only one variable Rn that you have, which expects the next frame. It gets that frame, he processes that and forwards it. And so there is no need to buffer out of order frames. He's not going to break his head. If he's getting even other frames, out of order frames properly without errors, he's not going to process them. So these are going to be creating only a problem for the sender because that guy is going on pumping frames thinking that all are going in order, right? But if things are not going in proper, then it's going to be very inefficient on a noisy link scenario. So that's where we are looking at, where go back and may actually perform bad when the error rate is high in the channel. But if there is not much errors and everything goes properly in order, right? Go back in is going to perform really good. So we should not say go back in is not going to be better approach. It works well under a less error rate channel where you're increasing the bandwidth utilization, right? Bandwidth utilization. But that's not the case on a noisy channel scenario, right? So noisy channel, higher probability of frame damage can happen, which have to resending multiple frames. So this can use up the bandwidth and can slow down the transmission. So why should we go back and retransmit all those n frames when say there is only one first outstanding frame that got lost, right? We can only send the damage frame, right? In your go back in example, if you can recall, the frame 1 was lost, but frame 2, frame 3, everything you have to go back and retransmit, right? So that is where we have to see how can we address this? How can we make it much more efficient under such noisy link channel? Why should I retransmit everything? Can I retransmit only that is damaged? But I need to have a mechanism to find out what was damaged. What is that only one that was damaged? This is where selective repeat tries to introduce some more logic in the features in the algorithm. So let's look at what is it. The first thing, the difference that we see with selective repeat ARQ protocol is the window size. It's not the same window size as the go back in. Again, it's a fixed window, but the size of the window this time is only half of 2m, right? Which basically means I can rewrite it as 2 to the power of m minus 1. So it is less. The size of the window is actually smaller compared to go back in. Sir, why smaller? We will understand that. But there is another very big difference. The sender window size alone is not half of 2m, but the receiver side also, the window size is half of 2m. So now you're bringing in the receiver side where the window size is again the same as the sender window size, which means both of them are, trying to track the same window size, right? What is of interest to the sender is again interest to the receiver. But you're not filling the pipe as you're filling in go back in. You're only half filling the pipe. Let's take it like that. Why? Because in selective repeat, we only want, duplicates, only fewer duplicates to compensate. We don't want to keep resending all those frames. Whatever is, the frame that is damaged only needs to be done. So there's going to be fewer duplicates to compensate when you have a smaller window size. Okay, so having said, let's look at this example. Can you now tell me what is the window size here? And what is the value of m, the number of bits that I've used for sequence number? So the window size, the answer goes like this. The window size, now if you look at the window size is 8. Yes. Why it is 8? The value of m is basically 3 bits that I've used for my sequence numbering. No, I'm sorry. 4 bits I've used for the sequence numbering. Correct? Yes or no? Meaning you see the window sequence number from 0 to 15 and then again Rapsel. So the 4 bits have been used in sequence numbering, But the window size, is half of 2 to the power of 14, which is 8. So we can again debate why it is not greater than 8 and why it is 8. It's the same scenario that we saw. You can apply that for your own exercise. So the window size is basically 8, and it's not just the center window size, the receiver window size is also 8. So receiver also has to now have 3 variables tracked, right? To track about, but the idea now is, okay, so first outstanding frame 0, next frame to send is SN, the maximum size is S size. Receiver is expecting in order frame, but if he's getting out of order frames, he's going to store and keep it, right? But let's look at how that logic works. I hope you're all in sync now. Sender and the receiver window size is half of 2m, right? Having said, look at this picture. If you look at the receiver side, there are 2 control variables, unlike 3 control variables. One is what is the the next frame that you are expecting. The receiver always expect an in-order frame, right? He's expecting frame 3. He's getting frame 3, he can deliver that, slide the window. But if he's not getting frame 3, he's getting some other frames. This time the receiver is not going to discard it, but he's going to keep storing that in the buffer. He's going to collect all those frames which are out of order frames. But he's not going to deliver all these frames unless he gets the in-order frame. He can only deliver in-order frames to the network layer, right? So he has to store all those out-of-order frames, but he can prevent the sender from retransmitting those out-of-order frames which are correctly received. So that can actually use up more the bandwidth. It's not going to waste your bandwidth. And whichever frames is not received, that only you have to selectively retransmit. That is the idea behind selective repeat ARQ protocol. So let's go and look at the understanding of this. So I want you to first look at the difference in this design compared with the, go back in approach. The first difference that I would always ask you guys to look at is the sender and the receiver window, half of 2m. The second difference I want you to look at now is the receiver can send either a positive acknowledgement or a negative acknowledgement. Positive acknowledgement meaning always asking for the next frame to send, right? Negative acknowledgement is asking for which frame I have not got or there is a problem. Negative acknowledgement 1 means, hey, come on, send me frame 1. I have not got frame 1 or something, that is problem with frame 1, right? So that is the idea behind the positive and the negative acknowledgement. The second difference that I want all of you to understand here is, unlike stop and wait and go back in, which was only using one timer for that protocol, here for every individual frame, there is going to be a separate timer. So you can track individually every frame. Sender can track individually every frame. That frame timer times out, he has to select to transmit only that frame. But the negative acknowledgement is a very nice idea that before your timer times out, if the receiver is sending, hey, come on, I have not got frame 1, then he can quickly retransmit that frame 1, right? He doesn't have to wait for the timer to time out to do that. So that kind of good approach is also introduced in selective repeat. So let's look at some examples before that. So this particular case is again telling why your window size is half of 2m and not something greater than half of 2m. So again, I want you to look at this picture here where, the forward channel is all good, but the reverse channel is bad, which means acknowledgements are getting lost, right? So he's sending, so in this case, the window size is 2 and m value is basically 2 bits, right? Though the sequence number is from 0 to 3, the window size is only 2. Okay, so when the frames are getting all successfully received, the window keeps sliding. As you know, for every slot that it receives, every frame it receives slides by 1 slot, right? So it has received 2 frames, it has slided by 2 slots, but then it's not got the status. So the timer of the frame 0 expires. He retransmits frame 0. This guy correctly discards because he's expecting, frame 2. But in this case, when the window size is greater than half of 2m, say window size is 3, and for every slot frame he receives, he slides by 1 slot. Now the window now goes on to the next cycle. He can also expect frame 0 from the next cycle. So when this frame 0 first cycles, times out, he transmits that frame 0. He erroneously accepts frame 0 in the next cycle, thinking that the frame 0 belongs to the next cycle. So this is a problem. That's why your window size is half of 2m. I hope the same logic that you applied and go back in, the same thing applies here. Why the window size here is half of 2m, nothing greater than half of 2m. Okay, so having said, both of them are half of 2m. But the algorithm, before getting on to the algorithm, I will just show you the illustration so that you can appreciate how it works. So if you look at the particular scenario, the first scenario is where, if you look at one of the frames are getting lost, right? So the forward channel, there is a frame getting lost. But unlike the go back in, it has to go and retransmit from where it started or which frame it's lost. Here, it's not going to do that. So let's understand how this works. So can you look at this picture? Tell me what is the range of sequence number that I've used? 0 to 7, 0 to 7. So what will be the value of m number of bits that I've used for my sequence number? M is 2 bits, 2 bits meaning 0 to 4, M is 3 bits. When it's 3 bits, you know it's from 0 to 7, again 0 to 7. But what will be the size of the sender and the receiver window when you're following a 3-bit sequence numbering? Half of 2 power 3, which is what? Half of 8, which is 4. So the sender window size is also 4, receiver window size is also 4, which means sender can transmit 4 frames without stopping and worrying for the acknowledgement. But for every frame that it is transmitting, it has a separate timer. This is the difference. And the receiver, though it expects RN in order frame, it can also buffer out of order frames. So keep that in mind. Now, let's look at the case. Now, so the sender SFSN is all pointing to 0 first. It starts to transmit frame 0 upon the request that comes from the network layer. Sends frame 0, starts the timer for frame 0. Receiver is expecting frame 0, is getting frame 0. It has slided by 1 slot, incremented the RN to RN plus 1, and is sending ACK asking for frame 1. Right? Now, the window sender has got acknowledgement 1 before the timer of that frame expires. So it slides by 1 slot, right? Stops the time. Now, the receiver sender now can send the next frame, frame 1, right? Start the timer for frame 1, but the frame 1 is lost. But it doesn't mean, right? It can keep on sending frames. So it is sending frame 2, it's sending frame 3 and all that. The receiver is expecting frame 1, but he's not got frame 1, but he's instead got frame 2. Here is an interesting aspect. Before the timer for frame 1 expires, the receiver, he has stored the out of order frame, but he has not delivered that to the boss, to the network layer, but is instead asking, hey, I want frame 1. How is he asking? He's sending a negative acknowledgement, putting frame 1 and asking, hey, send me frame 1. Right? But what is happening now? Receiver is getting frame 3. So though he is an out of order frame, he's not discarding, he's storing that in the buffer. But please understand, again and again, he's not going to keep asking for, hey, send me frame 1, send me frame 1 and all this. He's only going to not overcrowd by sending multiple negative acknowledgements. He'll send negative acknowledgement only once. If that negative acknowledgement say is getting lost, obviously the timer will time out. Yes or no? So you can select to retransmit that as well. But since the negative acknowledgement has come, right, before the timer times out, the sender goes on and resends that particular frame and restarts the timer. So look at how proactive here the selective repeat is. Before the timer for frame 1 expires, he gets a negative acknowledgement asking for frame 1. And so the sender selectively retransmit that frame alone. Right? And the beauty now is this, right? The sender has got frame 1, but as soon as he's got frame 1, right, he can now slide 3 slots. He can now slide 3 slots, right? And then go on to ask, send a cumulative acknowledgement. So the idea now is, though he has buffered out of order frames, he is waiting for the in order frame 1. But as soon as got his in order frame 1, he can now slide by 3 slots, right? And then send 1 cumulative acknowledgement. Now, this is where cumulative acknowledgement is actually implemented fully. And send 1 cumulative acknowledgement asking for ACK4. You understand that? So once ACK4 is sent, what he can do in the sender now, sender has got the status of all the 3 frames, right? The one that is already has transmitted. He has retransmitted selectively frame 1. And so once he has got ACK4, he can now slide by 3 slots, and then he can now further fill in the slots of the window, and he can keep popping it. So that's the beauty of selective repeat. The introduction of negative acknowledgement before the timer times out, you can quickly retransmit or selectively retransmit that. But though you buffered all your out of order frames, the receiver can now send 1 cumulative acknowledgement at 1 shot, which basically is, I've got all your other frames. So you can go and transmit your next set of frames. So that's the beauty in your selective repeat approach, right? I hope you're able to understand this. Let me take you quickly 5 minutes. I just want your focus here of how the algorithm is differing. The receiver side algorithm also is now much more complex, because it has to store out of order frames. right? And it has to slide the window and deliver the data to the network layer. All that comes into place. So I want all of you to focus now on the sender side selective repeat algorithm. How many variables are there at the sender side to track the window? The size of the window, the first outstanding frame, and the next outstanding frame. 3 variables. Initially, first outstanding frame, next frame to send is all frame 0 that I have to send. So I have initialized to 0. I'm indefinitely running my algorithm. I'm waiting for an event. What kind of events can happen? Network layer wants to send its data, so it sends a request to send event. Physical layer, you get an arrival notification event. It could be a positive acknowledgement or a negative acknowledgement, or a timer timing out for individual timers. So 3 types of events can happen. Yes or no? Okay, so let's look at this now. If your window is not full, Sn minus Sf is not greater than or equal to Sw, till that you could keep processing your requests and keep sending those frames. But if your window is full, you need to get into sleep mode. You should not process any more requests till you get the status of your frames. Okay, so my window is not full. I'm getting the data from the network layer. I make the frame, the next frame to send. I number this, the first frame, which is frame 0. I store that, keep the copy of the frame in the buffer to retransmit if needed, right? And send that frame and increment the value of Sn to Sn plus 1. You know, this is mod 2 power m, right? So as I increment that, I start the time. Now look at this. There's a difference in the start timer function here. The start timer here is starting the timer for every individual frame. So frame 0 has a separate time. Like that, every frame has an individual time. So this is the difference that you see compared to go back and there are separate timers for each frame. Now let's look at the next one. In the sender side, you're getting an arrival notification event. You're receiving the frame. You know that frame could either be a positive acknowledgement or a negative acknowledgement. Or if your frame is corrupted, acknowledgement is corrupted, then you're going to be silent. Your silent itself will alert by your timer timing out. But if the frame that I got is a negative acknowledgement, right, then I have to check what is the negative acknowledgement number. If the negative acknowledgement number is number 1, then I need to retransmit that particular frame alone. But say if my first outstanding frame is 0, right, and I have transmitted 3 frames till 3, right, my negative acknowledgement, I'm checking whether it is between SF and Sn. So if so, right, I go on to resend only that frame and restart the timer for that particular frame. Because before the timer times out, I'm getting negative acknowledgement. I selectively retransmit that frame and I restart the timer for that. Okay, so this is a case of negative acknowledgement. But if you're getting an acknowledgement asking for the next frame, this acknowledgement number, this acknowledgement number could be a cumulative acknowledgement as we saw also. So you're checking whether the acknowledgement number that you received is between SF to Sn. If so, right, whatever be the acknowledgement number that you've got, starting from SF till that acknowledgement number, you could purge all the copy of that frames that you transmitted for which you got the status, right? Stop the individual timers of those frames and keep incrementing your SF to Sn plus 1 till the acknowledgement number less than the acknowledgement number that you've got. So from that acknowledgement number, you have to start sending. So till that, you could slide your window, right? And you can purge all the copy of the frames. I hope I made it clear at the center side for positive acknowledgement and negative acknowledgement. Now, there's one more event that we have to look at, which is a much more important difference here. The timer times out. And the timer can time out for every individual frame. Whichever timer times out for that particular frame timer, you need to restart that timer and resend that particular frame alone. Selectively retransmitting only the frames that you have lost, status of. Right. So that is the beauty in your selective repeat. Right. Whereas in the case of receiver side is where there is a complexity. You looked at your stop and wait ARQ and your go back in ARQ. The algorithm of receiver side was very simple. You're expecting one in order frame. You get that, you process it. But here you might get even out of order frames which are correctly received. You might have to store that and keep it in your buffer before you send it and deliver, to your network layer. So all that has to be done. So I want few minutes of your attention. So look at this now. You have only one variable Rn. You're expecting what is the next frame. There are 2 Boolean variables that you're tracking. Whether have you sent negative acknowledgement or not. For that, you've set to false initially. And whether I need to send an acknowledgement, is acknowledgement needed? Again, I have a Boolean variable. So this is basically needed to track in case you're sending cumulative acknowledgement at one shot, right? You can send a cumulative acknowledgement for all the frames that you received. So acknowledgement needed Boolean variable will help you there. This is one thing which I want you to look at carefully. How are we implementing and abstract the algorithm, right? If you look at I'm having a window, receiver has a window, that is half of 2m. So for every slot in the window, I'm tracking the status of that, whether that frame is received in that slot or not. So I'm marking all the slots, right? Like an array, right? I mark all the slots to false initial. So whichever slot I've received, that slot I'll mark it to true. But I can only slide the window if I got the expected RN value, the in order frame, then only I can slide. But till that, I can keep storing the out of order frames that comes in, right? So to mark all those frames that I've got, right, I'm tracking them with a Boolean array with status false or true. Right? I hope it's clear. Now, let's look at this indefinite algorithm. Receiver is running. It's waiting for an event. What kind of events you can get? Arrival notification event, which from the physical layer, which means you're receiving a data frame. That data frame could be a corrupted frame or it could be a proper frame, right? If you're getting a corrupted frame, which means that you have to discard that frame, but you are expecting Rn of say frame 0, right? And you're getting a corrupted frame. You're now going to tell to the sender that, hey, come on here, I need frame 1, right? So that's something that I'm expecting, right? So I'm sorry, I'm expecting this particular frame 0, right? So whatever frame that you're expecting, right? And you've not sent a negative acknowledgement, but you're getting, say, either an out of order frame or a damaged frame. Now, in this case, it's a damaged frame. You've not sent a negative acknowledgement yet for that frame. Then you could go ahead and send negative acknowledgement asking for that frame, right? So whatever is the Rn value, you could send a negative acknowledgement. Once you have sent a negative acknowledgement, you're setting that Boolean variable to true. You're not going to repeatedly keep asking for, hey, come on, send me that negative acknowledgement, right? So only once you will send, so that you are preventing crowding of sending that frames and using up the bandwidth. This is again another nice feature. Okay, so this is one case. The other case is you've got an out of order frame. You're getting a sequence number in the frame which is not matching with your RN, like the example that I showed you. And say frame 1 you're expecting, but you're getting frame 2, right? You will actually store that in the buffer, right? But the idea now is you will not slide your window, right? So how are you going to do this? If you're getting an out of order frame and you're not yet send negative acknowledgement, then you will send negative acknowledgement asking for that particular frame, right? And set the negative acknowledgement true. So the same logic that you're using here. This is the case for out of order. This is a case for damage. Both the cases, what you're doing, you're sending a negative acknowledgement if it's already not sent. Now, let's look at this, right? If you're getting a frame which is proper, which is in the receiver window, but that particular frame is not marked, right? Which basically means you're getting an out of order frame. What you will do, you will go and store that frame. Say you're getting your transmitted frame 1, frame 1 is lost, but you're getting frame 2. You will store that frame 2 in your buffer, right? You will mark that slot of frame 2, right? That you got that frame. So that's what you're doing. You're marking that sequence number in that window to true. You're storing that frame, right? But you will not slide the window until you're getting your RN, right? The expected frame number. That is where this comes in. So even if you're getting frame 2, frame 3, all those slots you will mark, but you will not slide until you're getting your RN value. So this while loop, you see, you are checking whether the expected first frame RN value is marked, which means you've received that. If you have received that RN, then you will deliver that RN value, which that particular frame number, frame 1 to your boss, then slide by 1 slot, right? You could remove that copy from the buffer, right? Increment your value to Rn plus 1, and you can do that. But the case now is, say, I'll redraw this again for the benefit of understanding this. Say your 1, 2, 3, 4 is there. You got frame 2, frame 3, frame 4. All these are marked, but you've not got Rn. But then you're getting your frame 1 after you selectively sender relatively retransmit. So as soon as this frame 1 is received and is marked, what you can do now, this receiver can go and deliver this Rn, the data, remove this from the buffer, increment the Rn to Rn plus 1, deliver this, and this can keep going in loop till your Rn value that is there. You could keep delivering everything, and at one shot you could send one cumulative acknowledgement asking for the next one, say ACK 5. right? Just for an example. So the idea now is every time your slot is marked, your value of Rn is marked, you can deliver the data, purge that data from the buffer, increment the Rn to Rn plus 1, set the acknowledgement needed to true. But once you've completely decided how many of slots you've now received, right? You can come out of the loop and you check whether acknowledgement needed is true. If acknowledgement needed is true, then you send the acknowledgement for that current value of Rn. So in this case, it's a cumulative value, right? And so you could check one cumulative acknowledgement, not individual acknowledgements here. You could send one cumulative acknowledgement, right? And then revert the acknowledgement needed to false, a negative acknowledgement to false, so that you can again get started for the remaining new set of frames. Okay, so this is the algorithm that comes in. I hope you're able to understand selective repeat algorithm much more clearly, where this particular scenario that I showed you, right, would help you to basically understand this. So in this case, if you look at the ACK4 served as one cumulative acknowledgement. As soon as I got my frame 1, I could slide that many number of slots and I could send an ACK4. So that was the algorithm. That was the approach that you saw at the receiver side. And you're not overcrowding your negative acknowledgement, even though frame 2, frame 3 is counting, you're sending only negative acknowledgement only once. So this is the idea behind selective repeat, and selective repeat tries to address the issue there. And it becomes more efficient compared to the other two protocols because it reduces the number of retransmissions, number one. But complexity wise, selective repeat receiver processing logic is much more complex. Yes or no? It needs now more memory compared to go back in because it has to buffer up as the window size is large. It has to buffer up all the out of order frames. So the complexity at the receiver side is more, right? It will receiver will be able to reinsert the retransmitter frame in the proper sequence after it arrives. So the logic of processing is complex, right? But it comes with the advantage that it is able to now reduce the number of retransmissions. So that is the idea behind selective repeat and how it addresses the issues of go back in and improves the performance. Though the bandwidth channel utilization is not as good as go back in, it reduces the number of retransmissions and increases the efficiency of transmissions. So thank you for your patient listening. In real time, if you look at the kind of communication is bidirectional. Both the sender and the receiver can simultaneously transmit data frames. So instead of having a separate logic for receiver side and sender side, both has to come in the sender and the receiver, right? So which means that should I have to separately send acknowledgement for every data frame that I receive in every direction? The answer is it can be further optimized, and that is where an approach came in, where the concept is called piggybacking. Piggybacking is something like, you're carrying a load with you. So what we can do now is in your data frame that you're sending, say A talks to B, A sends its data frame, B sends its data frame. So B's data frame, I need to send a separate acknowledgement. A, when it sends a data frame to B, B has to send a separate acknowledgement. Why are you sending a separate acknowledgement? In the data frame itself that you're carrying, you have one more field which is carrying an acknowledgement of which carries the status of the previous data frame that you received. So in your data frame itself, which has a number, you're including one more field, which is the ACK field. That ACK will tell about the status of the data frame that you arrived, that you got from your sender there. So this way you can improve your efficiency, where you're piggybacking by carrying in your data the load of your arrived frames that you got from the other end. So this is called piggybacking. This is what is applied real time. But if you look at it from algorithm implementation, it will be much more complex to do that. So that's why we are showing it in a unidirectional, where one sender is sending data frames, the receiver is sending acknowledgement. But in real time, you could have data frames from both the ends, and you could send the acknowledgements in your data itself that you're carrying about the status of the frame that you received from the other party. Okay, so thank you guys. Thank you for your listening. I hope it helps.